This is our most recent work, and it's gone to a factory in Germany, and it's a open architecture assembly cell. So we've used 5 collaborative universal robots in an open environment protected with floor scanners to say that a person can't put their hand underneath any one of the cobots while it's doing an action. In general, it's okay to touch the cobots, but to put your hand underneath something as it's being opening or closing, it's just going to generate a pinch point and a no-go area. So we're using 5 robots. The first one has just completed a task, and this is the second guy doing multiple tasks. So it's picking up a printed circuit board, which the big one just put in there a while ago, and now is going to track it. We've got a CSV file for tracking all of the parts. So we've just done an assembly, and it's going to move Cobot 2 to number 3. Just got to go through a screwdriver first. So there's 2 screws, and we're tracking each piece of information all the way along. So here we've got torque and angle for each one of the screws. So it's Cobot number 3. Pick them up, and it's going to track it at that step and take an image. So now it's going to the end of line tester, close the pins, close the lid, needs to be RF shielded, and then Cobot 4 is waiting for the output. So pick the part, image, color, and straightness of pins, good part. Reach out to the cloud. We just closed off the file. Here comes the part, name on the label. And then tamp the part, the flat label. Then Robot 5 OCR is the label, see that it's printed correctly, and place it out. And this is that cell. So this shows the whole complete assembly of it. These guys are the control box for the robots, the main panel, and these racks are for the flashing boxes. There's 4 boxes there right in the middle of the screen. They're downloading software to the PCBs, and then these 3 big ones are for the end-of-line tester. So it's a standalone cell, and it's got a yellow scanner in view now. So this is the scanner which allows us to make the cell open, safe, and somewhat collaborative, in that if there's an action to be done, a person can go in, the scanner sees the ankles, and it suspends the action until the person leaves the area. So this is the kind of thing that we're doing. And just, okay. So that's really the kind of thing that we're automating in the area. And is that screen stop sharing now?
No, we can still see the video screen. Do you want to run the first video, the shorter one? Did you say it was Boston Scientific? Do you want to put that one up again? Because of course, yeah. We didn't see it, so I think it would be interesting to.
Oh, you didn't see it? Excuse me. Okay, that's good. Thanks, Shane. So.
Yeah, now it's up.
Is it? Okay. Sorry, I was unclear with that, but. So this is a person sharing the action with the cobot, and that's really what it's about in this particular instance. And that I'm just going to stall that there for one moment, so this is something we have certified, the idea of a cobot working alongside a person. And if you can see, the person can put their hand underneath of the end of arm tooling. Like there now, you've got a person approaching this cell, and the cobot is looking to pick up those 4 blue trays. So there's 2 things we've done. We've got an overhead scanner, which is looking for the zonal control, and that this is what's showing here. So we've got a zone there. So when the cobot's coming into that zone, we don't want the person here. So when there's no trays here, this gray space is the person's space. So with some training, we can say, well, come into here when there's something to do and don't come into the other one. And if you do, the cobot will go into a slow mode. We have also then had to certify the the cobot has got a force function which will stop if something comes underneath of it. And with what we've used, it's an E-Series Universal Robot that we've been able to test the force applied before it hurts. And we've certified that the end of arm tool that's shown here, so this is all smooth on the underside. So if a person puts a hand in, it will pinch, but it won't burst skin. And that there's a force that's acceptable. So we'll leave it drive on. So the job at hand then is to take the tray that the person has put down. These are labels. We're printing the labels, and these are the Tyvek, the lids. So we've got to separating these lids was a challenge because they're statically stuck together, and this is collecting labels. So it'll go on and assemble everything there now. This guy's just calling for work. So it's just to make a visual something that the robot's doing nothing, and this is the job at hand. Pick up the blue trays, bring them into the welding station, check the contents with the 3 cameras, put on the lids, close the welder, product coming out, place on the labels, take the image, and this is the product out the tray. So that's basically the cell, but we got best use of robotics in Ireland for this cell in 2020, just because we pushed the boundaries a bit to try and reduce danger paramount with screens and safety devices. So the safety device that we've used is in the ceiling, and that the primary safety device is the actual robot. And that was the only way that we could certify it, because we used a Pilz Magic Eye, and it was the most challenging device that we've ever taken to using. So